Hi everyone. Now we are going to discuss one of the interesting topics of number systems. See, I have written a question there. Find the remainder when 2 power 2024 is divided by 7. See, such a huge number, right? 2002 power 2024. And how do you divide that number by 7? Suppose if you would like to find the value of 2 power 2007 and then if you want to divide that big number by 7, it's not a great idea at all. So then how to answer this particular problem? Before we answer this, I just want to introduce one important tasks, important concepts. Why would I call it as a task? Because this is very much useful in order to solve these kind of problems easily. So that name of the concept is congruence modulo. What do you mean by this congruence modulo? Congruence modulo means, I'll just explain one example with the help of one example. Suppose you are taking a number 7 and you are dividing that 7 by some number 5, for example. 5 ones are 5, then you get the remainder 2, right? Now I am going to write this particular division in a different way. The different way is you are dividing that 7, right? 7 is congruent to, you have to read this symbol as congruent to. This congruent is different from our congruence in triangles. Okay, this is congruence in number system. So 7 is congruent to, you are dividing 7 by 5, right? What do you get the remainder? You get the remainder 2. So 7 is congruent to 2 modulo 5. This is what is congruence modulo. So that you can express any division with the help of congruence modulo. So here 7 means this is dividends place, and this 2 is the remainders place, and this 5 is the divisors place, right? We are not going to involve quotient anywhere in our congruence modulo. You understand? So 7 is congruent to 2 modulo 5. Now here, suppose if you are dividing a number A by some number B, then you get the remainder by some number M, for example, and you are getting the remainder B. Then how do you write this in this particular format? When A is divided by means A is congruent to, what do you get the remainder? This is the reminder's place, right? So remainder is B. So B modulo, what is the divisor? Divisor is M. So A is congruent to B modulo M, where A is the dividend as well as B is the remainder and M is the divisor, right? So this is what A is congruent to B modulo M. It has some properties. So what are those properties? For example, the 7 is there now. I am going to square this 7. 7 square is equal to what? 49, right? Now I am going to divide this 49 by the same number. So what will happen when you divide 49 divided by 5, 8s are 40, 5 9s are 45. So what is the remainder that you are getting? Remainder is 4. What basically the remainder here? Remainder is 2, right? When you are squaring this dividend, the remainder will also be squared, right? So it means 7 square is congruent to 2 square modulo 5. Is it true for all the numbers? Because we did 7 square smaller number. Let us go with 7 cube. What is 7 cube? 7 cube is equal to 343, right? So when 343 is divided by the same number 5, correct? So 5 6 are 30 and then 43, 5 8s are 40, remainder 3, correct? So here you get the remainder 3 now. It means 7 cube is congruent to 3 modulo 5. Now see here, cube here 7 because it is true for square. Is it true for cube? Let us see. 7 cube is congruent to 2 cube modulo 5. So 2 cube is equal to what? 8. Don't say that it is wrong because 8 could not be the remainder when any number is divided by 5, right? Because 8 can also be divided by 5. when 8 is divided by 5, 8 is divided by 5, what is the remainder? So 8 is divided by 5, 5 ones are 5, so the remainder is going to be 3. So 3 is the remainder. Therefore, we can conclude this as when A is congruent to B modulo M, then we can say that A to the power of K is congruent to B power K modulo M, provided B power K should be smaller than M. Of course, we know that because this is a division process. Okay, you have to remember this. When A is congruent to B modulo M, then A power K is congruent to B power K modulo M. Fine. And one more rule I would like to discuss here. 7 is congruent to 2 modulo 5, right? We understand when this 7 is raised to some non-zero power, right? Non-zero is nothing but it's a positive power. Suppose if I go with some number, I multiply 7, right? So when I multiply 7 with some number, let us say some 3. So 7 into 3 is equal to what? Which is 7 3s are 21. What will happen when 21 is divided by the same number 5? 5 4s are 20, right? So remainder 1. Now see, what is the remainder? You can write 21 is congruent to 1 modulo 5, right? 1 modulo 5. Now, is it true when this remainder is also multiplied by 3? 2 3s are how much? 6, right? So then 7 into 3 is congruent to 2 into 3 modulo 5, because 2 into 3 is equal to 6. But 6 is more than 5, right? When that 6 is divided by 5, you get the remainder 1 only. So 1 modulo 5. You understand? 21 is modulo 1 modulo 5. 21 is congruent to 1 modulo 5. So therefore, with the help of this, you can understand one more rule. You know what is that one more rule? A into K is congruent to B into K modulo M. So these two are two most important properties of congruence modulo. That is, when A is congruent to B modulo M, then A power K is congruent to B power K modulo M, as well as A into K is congruent to B into K modulo M. And I repeat, what is this A, B, M here? A is the dividend and B is the remainder and M is the divisor. Hope you understand. Right. Without wasting time, let's get into our problem. And please do remember this congruence modulo concept, because this is one of the most useful concepts in number systems. Right? Fine. Now, what is the remainder when 2 power 2024 is divided by 7? How do we start with? First of all, 2 power 2024, we cannot directly divide by 5 with the help of our congruence modulo. But let's see, will you be able to divide 2 power 1 by 7? 2 power 1 is smaller than 7. Even 2 power 2 is smaller than 7. But 2 power 3 divided by 7. When you divide 2 power 3, which is equal to 8, then you get the remainder 1, right? Let us use this information in order to find the remainder. Okay. Since we know 2 power 3, which is equal to 8, when 8 is divided by 7, what could be the remainder? 1 is the remainder, isn't it? So this is in which form? A is congruent to B modulo M. When A is congruent to B modulo M, we know something that A power K is congruent to B power K modulo M. But this 8 is nothing but 2Q is congruent to 1 modulo 7, 2 power 3 raised to which power in order to get 2 power 2024. Then just use your brain to get a number where 2 power 3 raised to which number to get exactly 2 power 2024 or nearer to 2 power 2024. For that, you take 2024 and divide it by 3. Right. So 3 6 are 18 and then 22. 3 7s are 21 and then 14 and 3 4s are 12. It means 2. What do you mean by that? If you raise 2 power 3 whole power 674, then 2 power 3 whole power 674 is congruent to 1 power 674 modulo 7, right? What is 2 power 3 whole power 674? 2 power 20, because remainder 2, right? It means subtract 2 from this. 2022, isn't it? Is congruent to 1 power anything is equal to 1 only, no? So 1 modulo 7, right? So now this is 2 power 2022, right? We want 2 power 2024. What do you mean by that? You need one more 2 square here. What do you mean by that? You just multiply by 2 square. Like which formula? A is congruent to B modulo M. Then A into K is congruent to B into K modulo M also, right? Then A into means we want K is equal to 2 square here. So that 2 power 2022 into 2 square congruent to, you got B is 1 into 2 square modulo 7. So this is going to be 2 power 2022 multiplied by 2 square is 2 power 2024 is congruent to 1 into 2 square is equal to 4 modulo 7. Right? Here 4 is smaller than 7. Therefore, this is what is the required remainder when 2 to the power of 2024 is divided by 7. So with the help of this congruence modulo, we can answer many more interesting problems of the kind, while especially finding the remainder when this kind of use numbers divided by this kind of numbers, right? Hope you are interested. Thank you.